Concrete is one of the mostly used materials in the world due to its unique properties such as high compressive strength, availability, and cheap price. However, concrete tends to crack when it's subjected to external and internal stresses and forces. The generated cracks significantly reduces the concrete lifespan. Currently, there are a wide range of crack treatment approaches. However, most of them are unsustainable when the crack generates in the foundation or the top surface of the structure, so we cannot detect those cracks.
Can we employ the principles of bioprocess engineering, fermentation, and nanotechnology to enable a bacteria to heal these cracks automatically, basically a self-healing approach? We use solid-state fermentation principles plus nanobiotechnology concepts to design a process to make the bacteria overcome these issues. We immobilized bacteria on ion nanoparticles to make them able to tolerate these conditions. The results have shown when we made this mixture into the concrete media, it shows significantly higher calcium carbonate production as well as helping the bacteria to overcome harsh concrete casting conditions and extreme pH. We have seen it heals the concrete crack within a month period. Besides healing efficiency, we have seen improvements in mechanical properties of the concrete, such as significantly higher compressive strength.
Also, it reduces the water absorption, which is very important in the marine structures or foundations.
What we have developed is not just limited to the concrete. We can use this technology in wastewater treatment, soil stabilization, and many more applications. And I'm very happy if we can collaborate with industries and companies in New Zealand to make these products happen into the market as soon as possible.